Hi, this is Mr. Hodgen, and this is the Unit 6 review for the quiz. So I'm going to go through each problem. Just make sure you can do all this on your own before you take the quiz. So here we go. Let's fill out this basic t-chart. Don't have to graph it. So we'll just plug in the x into this exponent right here. So we'll have 4 to the 4th power. We'll have 4 to the 3rd power, and 4 to the 2nd power, 4 to the 1st, 4 to the 0, and then the negatives, like so. So the value they give you for x is just the exponent. The base, just 4 in this case, stays the same for all of them. Alright, let's start with the easy one, 4 to the 0, which is 1, and we'll go up. 4 to the 1st power is 4. 4 to the 2nd power is 16. That's 4 times 4. 4 to the 3rd power, 4 times 4 times 4 is 64. And then 4 times 4 times 4 times 4 is 256. Now, remember with the negative exponents that they're kind of paired up. So to the 1st power to the negative 1st power will look very similar. So if 4 to the 1st power is equal to 4, or 4 over 1, another way of writing it, then 4 to the negative 1 is actually 1 over 4, the reciprocal. So if you know the positives, you can just take those and take the reciprocal of them, and that will give you the negative exponents. So remember, negative exponents are not negative numbers. They're fractions. So negative 2 here as an exponent is a positive fraction. And then we can just alternate back and forth. So we have 4 to the 3rd is 64. So 4 to the negative 3rd is 1 over 64. Very small fraction. And you'll see these negative exponents a lot in science when they're talking about things that are microscopic size. So they'll say it's so many inches big, or 4 to the negative 4 inches big, which is really, really tiny. That's how they measure microscopic or atom size organisms. Alright, so there's just a basic t-chart that we don't have to graph, so we can move on to the next. Okay, create a table for f of x, which is equal to 3x, and g of x, which is equal to 3 to the x power. So really just comparing the differences between these two. I've already set up the table here, or the chart, how we're going to graph it just to save time. So we're going to stay in the positive region, so we're going to start both of them at 0, and just go up to maybe 4 or 5. And you really have to know, well, you don't have to know what you're going to go up to when you start here. You just have to figure out the numbers and kind of see where a good point is to stop. It differs between each problem. So just plug each of these in. So 3 times 0 is 0. And then 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3 times 5. And here we have 3 to the 0 is 1, 3 to the 3 is 3, 3 to the 2nd is 9, 3 to the 3rd, which is 9 times 3, is 27. And we have 3 times 27, which is 81, and 81 times 3, which is 273. Alright, and we can go ahead and graph those. So first, let's do f of x. So start at 0, 0, and 1, 3, 2, 6, 3, 9. So you can see this pattern forming. It's very familiar. Slope, right, y-intercepts. And then we have here where it's slightly different. So 0, 1, 1, 3, so they overlap at 1, 3. You can see both of these are the same. And then after that, g of x starts getting bigger much faster. So 2, 9, 3, 27, and then 4, 81, which is really off the scale for us, so we're just going to graph it as it just keeps going up really fast. There we go. This is the g of x, and the blue was the f of x. Now, if you don't use the exact same scale, it doesn't mean it's wrong. This is just one way that I did it. Okay, so what about the patterns? Okay, so g of x grows faster. It gets bigger a lot faster. So that would be suffice for this. G of x grows faster. And you can see that from the table as well as the graph. Numbers get bigger here, the graph gets larger here. And which one's linear and exponential? So linear would be the one that increases by sums, and exponential is the one that increases by factors. Here's what I mean. So look at f of x, and you can see that from here to here it goes up by 3, a sum of 3. So you add 3, basically. Add 3, add 3. So by definition, that makes this linear, the fact that it goes up by adding. Okay? So our linear function will be f of x, okay, which by default will make our exponential g of x. And how do you know? Okay, so linear increases by a sum. By, I'll say adding. Or, in other words, saying that it's a sum. Whereas exponential increases by a factor or multiplying. By multiplying or a factor. So on g of x here, you actually multiply by 3 instead of adding 3, and that's what by definition makes this exponential. Multiply by 3 from one step to the next. So very similar, except that one multiplies, which is exponential, one adds, and that's linear. Alright, now for some exponent rules. Now there's a few basic rules that you want to make sure you follow. Let's go over those first. If you have some exponents, such as this, and make it a little smaller, 3. Just remember this is counting. When you're multiplying here, that's like counting. How many do you have? Well, we have 2 x's here. That's what x squared, x to the second power means. And here we have x to the third power. Right? So altogether you have 5 x's. So in a sense, it's kind of like taking 2 and 3 and just adding them up and get 5. So we added the exponents. So that's one basic rule. Another basic rule is when you have a power to a power. So something like this. X to the second to the third, which means x to the second times x to the second times x to the second. And by using the first rule over here, we'll just add these up, which means it equals x to the 6th. So you can see here, they both have the same exponents, 2 and 3, 2 and 3, but depending how it's written, you could be adding and get 5, or multiplying and getting 6. Now how can you tell the difference? Well, you can see how we have 2 different bases here. There's an x and an x. That's how you know you're supposed to add these. This has 2 exponents, but only one base. It has one single x. So when you have 2 exponents, that lets you know you're supposed to multiply them. Okay? And don't forget, negative exponents are fractions. They're not negative numbers. So something like x to the negative 2 equals, this helps, put it over 1, equals 1 over x to the positive 2. So this is a positive number, even though it's a negative exponent. It's a reciprocal. And so those 3 basic rules get you through most of these. And then we'll talk about the division as well, and that's where things just kind of cancel out. So if you have 2 x's on top, 4 on the bottom, just think about 2 of these x's canceling out 2 of those x's, and you're left with nothing on top, so we put a 1, but there's 2 left over on the bottom. So it's kind of like canceling out. Alright, so given those, we can solve pretty much everything here. Alright, so let's look at first the coefficients. So negative 5 times 3 is negative 15. And we have x to the negative 2 and x to the 6. Remember, add those. We have two bases, x and x. So we add those, which is negative 2 plus 6, x to the 4th. So treat these like individual problems. Really, these are going to be broken down into smaller problems to make it easier. Okay. Same thing here. We have three smaller problems. We have the coefficients, which operate as usual. Just multiply them. And two variables this time. So we have the x's. Do those in its own step. So x to the 2nd, x to the 9th is x to the 11th. Add them up. And then repeat it one more time, but for the y's. So 7 y's we have here, 12 more we have here. So altogether you have 19. So always easier if we just break it down to smaller pieces. Probably put an equal sign here as well. Number 5, 3/4 squared, which is 3 over 4 times 3 over 4. Multiply the tops, 3 times 3, which is 9. Multiply the bottoms, 4 times 4, 16. Likewise, you can kind of just raise the bottom and the top to the 2nd power. That's another way of doing it, and just say, well, it's 3 to the 2nd over 4 to the 2nd, which gives you the same answer. Either way works. Okay, number 6, let's just increase it a little bit. So here you can see we got that power to a power on the outside. We got two exponents, so we're going to start using this second one where'd it go? Where you start multiplying exponents. So we have the exponent on the outside. That's when we start multiplying. So you want to do those first. So let's do that first. So we're going to have, be careful, you're going to have to do negative 3 to the 2nd power, which is 9. You're going to have to do x to the 4th to the 2nd power, which is going to be x to the 8th, multiply this time. And then y to the 3rd to the 2nd power, which will be y to the 6th, multiply again. I want to do that first. Anytime you have the two powers, two exponents, do that first. And the first part here, you notice I just ignored it. I'm going to bring it down. And now this looks like a problem like number 4. Right, where we just have coefficients and variables, and we just have to combine everything together. So we have negative 2 times 9, negative 18. We have x to the 6th times x to the 8th, which is x to the 14th. We're adding them now, right? So we have two different bases, so we're adding them up. And then y to the 3rd and y to the 6th. So 3 and 6 make 9. There's your final answer. So just a little extra step. Just remember to do the same thing to the numbers as you do to the exponents here with the variables. Sometimes people forget that we had to do negative 3 to the 2nd power also. Okay. Once again, we have a power to a power, so I'm going to take care of this part here first and really just ignore the second half until later. So we're going to have negative 2 to the 3rd power. Now be careful, that's not negative 6, it's negative 2 times negative 2 times negative 2, which makes, let's see, negative 2 and negative 2 is positive 4. And then positive 4 and negative 2 make negative 8. So not negative 6, but negative 8. And then the x, remember multiply these, it's x to the 24th. And now we can combine these. So we have negative 8 times 3, negative 24. And we have x to the 24th and x to the 4th. Add them this time. So we have two bases, so 28. So here we start the dividing. So what you want to do here, get a little bigger, is first take care of the numbers like we did before and just treat it like a fraction problem from the 6th grade. Don't do anything different here. So ignore all the variables, and we'll get, fix that real fast, ignore the variables, and just reduce this fraction. So divide top and bottom by, let's say, 3. 3 goes into both, so 15 divided by 3 is 5. And 12 divided by 3 is 4. So that's the beginning, just simplifying just those, just the coefficients. Next we have two small problems. So just like before, break them up into smaller pieces. Don't try to do the whole thing all at once. Alright, so this says there's 6 x's on top and 4 on the bottom. So here's what you're doing, but we're not going to do this for every problem. But there's 6 x's on top, like this. And then on the bottom, there are 4. And if you're ever not sure, you can always do this for any problem. It might take a while, but you'll get the right answers. So what happens is that we have 1, 2, 3, 4. 4 of them canceling out. So we have same thing on the top and bottom canceling out, and we have 2 x's left on the top, which is the same as x squared. And then we can do the same thing here, but you'll notice that really, how can else you get the 2? What other way can you get the 2? Well, 6 minus 4. Really just taking away the ones that cancel out from whatever we have left over. So same thing here, we'll have 11. We'll just cancel out 4 of them, so 11 minus 4 is 7. And let's do that different color. And there you go. There's the final answer. Okay, let's go to number 9. Here. All right. Now, a good way to look at this negative exponent, remember this is a fraction, but the fraction part only applies to the exponent here. So what we're going to do is we'll end up just leaving that 6 right alone on the top, but this one part right here, x to the negative 9, that's the same as 1 over x to the positive 9. And since we have a 6 already on top, we'll just have to put an x to the 9th on the bottom. No need to put the 1 on top, since we have a 6 already there. But just don't move the whole thing to the bottom. So something different would be is if there's parentheses here, then we'd move the 6 as well. Okay, a little more practice. Okay, once again, just take the coefficients and reduce them. So we can divide top and bottom by 3. Okay, negative 2. Negative 6 divided by 3. And 15 divided by 3, which is 5. All right. Next, we have some negatives and some positives. So what we're going to do first is just move negatives. Negatives move. That's what they do. They don't stay in the same place. So this negative x exponent on top, I'm going to move it to the bottom. Same thing here, this negative y exponent, I'm going to move it to the top. So what we're going to have is the x to the 3, that's positive, that's staying there. We'll have that y to the 8th, that's staying there. So these did not move here and here, but the ones that are negative will move in blue. So this x to the negative 4 is now on the bottom, and it's a positive 4, since I moved it. Okay, the y to negative 4 on the bottom is moving to the top, and that's going to be a y to the positive 4. So no more negative exponents. So before we start canceling or anything like that, we want to just get rid of negative exponents. Now we can simplify. So the negative 2 stays put. You notice how there's no x's on the top and there's no y's on the bottom, so I'm just going to count these up. So we have 4 y's here, 8 here, and should we add these or multiply? Remember, if there's 2 bases, that means we add. So we're just counting them up. Y to the 12th, 4 plus 8. And on the bottom we have 5, and then x to the 3 plus 4, 7. X to the 7. And there's our final answer. Number 11. Right, let's take care of the negative exponents first. As you can see, when we have a negative exponent, we tend to take care of it and make it positive first before anything else. So negative exponent means flip. So you can move the 2 to the bottom and 3 to the top, which is the same as just flipping the whole fraction. And once you've flipped it, it is now a positive exponent. And then you can simplify that. So we always try to get rid of the negative exponents, then simplify them out later. So that's going to be 3 to the third power over 2 to the third power. Or 27 over, not 6, common mistake, that's 8. 2 times 2 times 2, 8. And there's your final answer. Okay, almost there. Now don't let this get to you. I mean, this is just the same thing we've been doing. There's just now x, y, z. There's 3 variables, but the steps are identical. Just do it one more time. So reduce the fractions, divide top and bottom by 7. So 14 divided by 7 is 2. 21 divided by 7 is 3. Take care of the variables. Now this is going to be nice because we have the same amount on the top and bottom. So 2 ways of looking at this. You can subtract them like we have in the past. 6 minus 6, which is 0. X to the 0 power is 1. Then we write times 1, which we really don't need to write 2 times 1. That's just 2. Or you can just see it as the same thing on the top and bottom, which means they cancel out when you're multiplying. Okay? So really, there's not going to be any x's in this answer because they're the same amount on the top and bottom. We can do the y's. Now we have 8 on the bottom, 2 on top, which means 2 of these 8 will be canceled out. So that will cancel out and leave this with 2 less, which is 6. So we're going to have 6 left over on the bottom. And similar here, we'll have 5 on top, 3 on the bottom, so 3 of these 5 will be canceled out, and you'll have 2 left over, because 3 of them got canceled out. Started with 5. So we have 2 left over on top. And there's your final answer. How do you know it's a final answer? Well, you can only have one of each variable, so we couldn't have a z here and a z here, or variable in different places. And there's no negative exponents. So, and the the numbers are all reduced. So 3 things. Numbers reduced. We have one of each variable, or the variable cancels out completely, but we don't have more than one variable. And there are no negative exponents. Everything's a positive exponent if there are exponents at all. All right, lastly, 13. One more time. Should be enough practice. Be really good at this by now. And it's so repetitive. Once you get the hang of it, it becomes almost boring, which is good. That means you know how to do it. So let's divide top and bottom by, let's say 2 goes into both. So 8 divided by 2, 10 divided by 2. And once again, we have negative exponents, so I'm going to take care of those first. So the black here are not going to change. So it's already next to the 4th, that's positive on bottom. This y to the 2 is positive on top, leave those alone. And then the negatives, those are the ones we want to move. So now we have an x, the positive 3 on the bottom, that moved, because this was negative. And the y to the negative 2 on the bottom, we're going to move to the top. And now we have, remember, we're not done because we have more than one variable, so let's combine those together. Negative 4. And then we have 2 y's here, 2 y's here, all together, 4 y's. We have a 5, and then we have 4 x's and 3 x's, so we have 7 x's total. There we go. So that's the end of that page. It's good to practice those maybe several times to make sure you really got it down. So in general, take care of double exponents first when you have the power to a power where you have to multiply. Do those first. Take care of negative exponents next. And then go ahead and add them up if you need to. Add up exponents as you need to. So it doesn't always have to go in that order, but in general, yeah, you want to do this first anytime you have to multiply power to the power, then take care of any negative exponents, and then at the end, if you need to combine some two bases together and add them, and you'll do that next. Doesn't have to be, but usually that's the order it goes. Alright, let's flip it over and look at the graphing. So it's kind of like what we're doing on number 2, where we had to graph two of those functions, but the functions, one of them is just a straight line. So this will be a little more straightforward. And I pre-numbered all the graph here just to make it faster. Notice how I space it out just so I use more of the graph. It's not wrong if you don't do that, but it does make it easier to do. Okay, so let's start off with 0 since we don't have any negatives here. And I'm just going to count up. 1, 2, 3, 4, and 5. And since y equals 16, these are all just, 16. So that's just a horizontal line at 16. Just like so. And then we can try here. So we have 2 to the 0, which is 1, 2 to the 2. I'm sorry, 2 to the 0, 2 to the 1, 2 to the 2, which is 4, 2 to the 3, which is 8, and so on. You catch on to the pattern. And we graph this one, 0, 1, there, 1, 2, 2, comma 4, 3, comma 8, 4, comma 16, and then 5, comma 32, which 22, 4, 6, 8. Yeah, so that would actually go all the way up to here. That would be 32. Now the answer is where these intersect, which you already can see from the tables. So once we saw this happen, same coordinate, we knew 16, 4 was the answer. The x is the answer. X equals 4 is the answer, which we can see here from where they intersect. Right there. So as we solve this, since we know x equals 4 right here, that's where they intersect, you can expect the answer to be 4 here as well when you solve it algebraically. So here's how you solve it algebraically. You want to get both sides to be the same base. So if there's a 2 on the left, let's make 16 2 to some power. And you just have to figure out, well, 2 to what power is 16? And since this is rather small problem, we already know that, well, 2 to the 4th is 16. And if the bases match, that's how we get the exponents to be equal to each other and we get our answer. But we have to have the bases equal to each other to say that this is the answer, x equals 4. Okay. And just for fun, let's do it in reverse for this one. We can solve algebraically first, so we know where it should intersect on the graph. So first, to undo the multiplication, so I'm going to divide, this is 3 times 3 to the x, so I'm going to divide by 3 both sides. I'll do an order of operations backwards. I have multiplication and exponents, so do the multiplication first. So I have 3 to what power equals 27 divided by 3, which is 9. And then write these as the same base. So this is a 3, this is a 9. Rewrite it as a 3 on both sides. So 9 is 3 to the second power. Therefore, we know if the bases are equal, 3 and 3, so are the exponents. X equals 2. So we can expect, when we're graphing this, that they're going to intersect somewhere along this line on x equals 2, the x-axis. Let's go ahead and do this t-chart, see that they do. So like before, it's just going to be straight horizontal line here. And they're all 27. So I expect they're going to intersect here, so that the next graph will come up somewhere along these lines and intersect right here. Alright, so same number, 0, 1, 2, 3, 4. We'll stop there. So to the 0 power, so we have to do this part first. So 3 to the 0 power, which is 1, and then multiply that by 3. So it's kind of working right to left. Exponent, then multiply, order of operations. So 1 times 3, 3. Okay, we'll have 3 to the 1, which is 3. 3 times 3, 9. And you'll see the pattern just continues the same way we expect it to, multiplying by 3 each step. Now you can see I'm not really going to go up to 273 or 81. I'm just going to kind of stop to and where they actually intersect. So 0, 3, right here, 1, 9, 2, 27, right where we expected it, and then it's 3, 81, which goes off the graph, so I'm just going to continue it going increasing really high so that it would get to 81 at 3. Okay, so let's do a few more of these, 16, 17, and 18, but without the graph. Let's just solve them algebraically only. Okay, so we got, and it says to check, so we can do that too. Remember, rewrite these as the same base. So 4 to the x. 4 to what power? Well, 4 to the second power is 2. So therefore, x equals 2. The bases are equal, so are the exponents. And we can just plug it back in and check. And yeah, 4 to the second power, does that equal 16? And yes, it does. So that's your check. Okay, 15. We got to undo the multiplication first, so I'm going to divide. 5 to the x equals 25. 5 to the x equals 5 to the second power, which is 25. Therefore, x equals 2. There we go. And just mentally, we can plug this in. 5 to the second power is 25. 25 times 2 is 50, and it matches the right-hand side. So lastly, we have a subtraction here on this one. So undo that by adding. So 3 to what power is going to equal 27? All right. So 3 to what power equals 3 to the third? Yeah, 27 is 3 to the third. So we have x equals 3. And that's how you solve those algebraically. Same way we do with normal equations. If it's subtraction, we got to add. If it's multiplication, we have to divide. So those have not changed. The steps have not changed. All right, let's look at the last page. We're a little bit almost there. Solve a few more. So we have both addition and the multiplication, so let's undo both and order of operation backwards, so we'll do the addition part first. So let's subtract. 5 times 2 to the x power is now equal to 80. Undo the timesing, multiplying by dividing. So now we have 2 to what power equals 16. 80 divided by 5 is 16. And then rewrite these as the same base. So if this is a power of 2, so must this be. So 2 to what power? 2 to what power? So 2 to what power is 16? Right, after a little investigation, you'll figure out it's 4. Bases are the same, so are the exponents, so x equals 4. And we could check these the same way as we did on the other side. Okay, almost there. We have subtraction and multiplication of a third. We're going to undo the subtraction once again by adding. 0. So we got a third times 3 to the x power is now 27. And we can undo the third two ways. We can divide both sides, multiplication of a third, so you can divide both sides by a third. but more commonly we multiply by the reciprocal, 3 over 1, which gives you the same answer. So now we have 3 to what power equals 27 times 3 over 1, which is 81. Same base, so we got 3 on the left. Let's write 81 as 3 to the power. And once again, you have to play with this a little bit if you're not familiar yet with all the powers of 3. So start multiplying them out. 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 4 times we have to multiply 3 to get 81. Calculator's handy at this. So once again, x equals 4 again. There we go. So there's the end of the solving. Let's do a little bit of the word problems here. More real life stuff. We calculate how fast something spreads exponentially, or grows exponentially, or shrinks exponentially. And used in science an awful lot. Now we noticed on the homework that there's usually a starting value and then a factor by which it's growing. Okay, so let's look at this. So the starting value here with random acts of kindness starts with 14 members. So that's where it starts. And then it's going to grow by a certain factor, in this case, a factor of 2. And this is just the format we discovered throughout the lessons. That we're starting with 14 if it grows as a factor of 2. So every time I multiply by 2, it grows another factor of 2. So 2 to the n. And please use the variables that are given to you. So if it says s of n here, let's use that here. And you have to have an equal sign for it to be equation. You can't just put 14, 2 to the n. You need to have the left side here as well. And then just use that. So find the total number for 4. So plug in 4. 14 times 2 to the 4th power, which is 14 times 16, which is 224. And we're talking about students that are complemented, so you can write students, student complemented. Write it out. Don't abbreviate or shorten it. Be very clear what your answer means. There we go. So again, we have a starting amount and some factor it's growing by to the n power, and use the right variables that are given. So on number 22, we read this. It says it's starting at 96 players. This time it's growing by a factor of a half. Half are eliminated. But technically it's not growing, it's shrinking. But that's how much it's shrinking by, is a half. And then to the n power. And then let's use the right variables. That's p to the n. So we have p to the n. Now we can just use that. P to the 5th power equals 96. And basically you're going to multiply 96 by a half 5 times. What that means. So 96 times 1/2 5 times is going to be 32. And 96 times 1 over 32, or same thing as 96 divided by 32, is 3. And 3 what? 3 players remaining. There we go. There's the end of your review. You want to be able to do this all by yourself, though. I know it looks easy when I'm doing it, but please go back, print out a blank one, do it again until you can do it by yourself. Okay? All right, good luck.